Hello everyone. Today we are going to discuss an interesting question. This question was asked in TCS NQT examination that was held on 15th of March 2025. Directly we will move toward the question. The same question I have got the same question that was asked in a test on CodeChef platform. So we are given three numbers. Chef has three numbers A, B, and C. He can do the following type of operations: select two numbers amongst A, B, and C, add one to the selected numbers, subtract one from the remaining number. Determine whether the chef can make all the three numbers equal after applying the above operations any number of times. If yes, output the minimum number of operations required by chef. We are also given the input format. The first line of the input will contain a single integer t, denoting the number of test cases. Each test case consists of single line containing three space separated integers A, B, and C. So let me tell you the same exact wordings and exact questions were with the same test case was been asked in TCS and QT. Only instead of A, B, C, it was given P, Q, and R, but that is okay. Let me just explain you the question what it is saying. So we are given three numbers A, B, and C. If we can choose any two numbers from A, B, and C. So let's say I am choosing A and C. So I'll increment A by 1. Also I'll increment C by 1 and decrement B by 1. Now how many times I do need to do these things? Until and unless I get all the three elements to be equal, like A equals to B equals to C. When this is done, we need to stop and we need to give the number of operations to make A equals to B equals to C, right? And what we need to get, we need the minimum number of operations. And if we are not able to make the three numbers equal, then what we have given here is we need to return -1. So let's take the example of the first example, the first test case, 1, 1, and 2. Let me just walk you through the test case and the operations that we'll do. For example, the first test case is saying A equals to, I'll write here A, B, and C. Okay, so 1, 1, and here it is 2. Please try to understand the test case first. So for the first operation, if what I need to do, I will increment A and B. Okay, so if I am incrementing A and B, A will become 2, B will become 2, and C will become 1, because that I do need to decrement. If again I will be doing, it will become 3, this will become 3, and this will become 0. So we are not able to make A, B, and C equal. That is why the output is coming out to be -1. Let's take another example, second test case. Okay, where we are given numbers as 3, 7, and 3. For the first operation, what we will do, let me first write it in sorted order. 3, 3, and 7. These are the three numbers A, B, and C that we are given. If I am incrementing this by 1, this will become 4, this will become 4, and this will become 6. Right, I'll use red pen only. And again, if I am this was the first time the operation that I performed. For the second time, I'll again increment this by 1, again increment it by 1, and decrement it by 1, 5. So here we got all the three numbers to be equal, and the number of operations were 2. So in output format, we are given here the operations to be 2. This was -1. Now for third input, that is 4, 4, 4, the numbers are already equal, so we don't need to equal them, and the output is number of operations will be 0. For the test case 1, 2, and 3, let's check. For 1, 2, and 3, if I'm incrementing, it will become 2, it will become 3, and if I'm decrementing 3, that will become 2. If again I'm sorting it, 2, 2, and 3. Now this is the similar case that we came across here itself also, that two numbers and one small. If I'm incrementing here 3, 3, and 2. So we can see here now that we won't get any case for which it will become, all the three numbers will become equal, right? So that is why the output here coming out to be -1. Okay, let us analyze this last test case here. For 1, which is odd number, in first operation, here the parity is changing to even. For 2, the parity is again changing to odd. For 3, which is actually odd, the parity is changing to even. So we can see here again, this we just wrote in sorted. In next operation also the parity is changing, right? So what do we observe from this test case is that in every operation the parity of the numbers is changing. What is the parity? If the number is even, then it is changing to odd. If odd, then it is changing to even. These are in first test case also. Even if the 373 test case also, here we can see that the parity is changing. Like if it is odd, then it is even. For every operation the parity is changing, and when all the numbers are equal here, 5, 5, 5, since the numbers are equal, obviously the parity will be same. may it be odd or even. Here in this case it is odd. So first key observation that we got here is that if the parity for the numbers to be made equal, the parity should be same, right? The three numbers parity at initially also, that should be same. Let me again tell you, through the first example that we saw here was 1 1 2. Here the number 1 1 and 2, this cannot be made equal, that is why the output was given out to be -1, right here, because here the parity, initially the parity of all the three were not same, but to make them equal at the end, the parity should be same. And since we are only incrementing or decrementing it by 1, every operation the parity is changing. So we, if the all the parities are different or any of the two are different, then we won't be getting at any cost equal number at any by performing any number of operations, right? So first key observation that we found was here that all the numbers A, B and C should have same parity, because if in first case we can see the parity is not same, 1 1 and 2 it is not giving. Here all the three numbers are odd, we are able to make them equal. Here all the one is odd, even, then odd, different. Then now here with this we can clearly understand by a theory, like suppose if we are subtracting an even number from another even number, what we will get, the output would be even. For example, I am subtracting a 4 from 8, we will get an even number, right? Now if I am subtracting odd number with an odd number, we are getting an even number. For example, here if I am taking 7 minus 3, we got 4, which is an even number. And if the numbers are odd, suppose another, if I am taking odd minus even, then what we will get here is suppose an odd number of 5 and even number 2, here we are getting an odd number 3, right? So when the difference is coming out to be an odd, we won't be able to make the numbers to be equal, right? Because we are only given the operations of incrementing by 1 and decrementing by 1. At the end, the final goal is to make all the numbers to be equal, which means all their parities will somehow will make them to be equal, right? So that was our first observation. If we can clearly light one thing, that if three numbers are having different parity, that means they has to be either odd or even. If they are not, then we will clearly return -1. Next, what we need to do here is, next let us observe another pattern. In let's see the second test case here, the 3373. Here the total sum was 3 plus 7 plus 3, total 13, right? Here again, this was I just wrote in second. In first operation that we performed, the sum was 4 plus 4 plus 6, that is equals to 14. In second operation here, 5 plus 5 plus 5, that is 15. So in every operation that we are performing, the sum of the three elements is incrementing by 1, right? So now how we can see, we can consider this. What we will, that first we need to now find out is the optimal target value, that is here 5, for which all the three numbers that were given came out to be equal, right? Let's suppose the sum of all the three numbers, the sum of all the three numbers would be A plus B plus C, and at the end of all the operations, that would be suppose I am considering x will be the value when all numbers are equal, right? Here all the numbers are equal, so their sum will be what, 3 into x, right? Now the number of operations we can directly get from here is, as in every operation the sum was incrementing by 1, right? So total of if we can get the number of operations by subtracting the final sum with the initial sum, that was s. Let me just explain here. In the same, for example, here the sum was 13. In the first operation it became 14. In second operation it became 15. When the final sum we subtract the 15 with 13, we get the output to be 2, and the number of operations we performed are also 2. So we got that this will give us the operations for which that was what we need to find out, the number of operations. Now what we need to do is we need to find the minimum number of operations. So we need to minimize this x, for which all the three numbers will be equal. In this case it was 5. how we can make this x to be minimal? This x value we can one thing that we have considered here are a and b and c are in sorted order, like we will be first sorting them, right? This is the initial case that we are considering. Now we know that all the three numbers are having same parity. Now since b and c are having same parity, so their sum b plus c will always be even, right? Their sum will always be even, and we can consider this to be, now since a and b are in a sorted order, a is the minimum value, b is the middle value, and c is the largest value, right? So we are b plus c are always will always give an integer value, so we will make this as x. Now why we have made this as x? Because x will be always an value between b and c, right? So now the number of operation was given by 3x minus s, right? And x value we are making it to be b plus c by 2. So we are coming up with the formula of finding the minimum number of operations to be minimum operations as 3x value that we got here is b plus c by 2 minus a plus b plus c. Now let's recheck it how this formula is giving us our answer. Let's take a different test case. I am considering it as 4, 8 and 12. Let's this is an already in sorted order, so I'll increment 4, it will become 5, it will become 9, and this will become 11. Again if we will do the operation, it will become 6, it will become 10, and it will become 10. Again it will become 7, it will become 11, and it will become 9. Again we will do, it will become 8, it will become 12, and this will become 8. Now we will just sort them, 8, 8 and 12, and now if we are performing here again, so it will become 9, 9 and 11. Once again if we'll increment them 10, this will become 10, and one decrement, we are getting the result, right? So after how many operations we have got this? 1, 2, 3, 4, we just sort this, 5 and 6. So output here should come out to be 6. Now let's check for a, b and c to be 4, 8 and 12, our formula is giving the answer or not. Okay, for a equals to 4, b equals to 8, c equals to 12. What will be the value of x? That will be, say, b plus c by 2, that is 8 plus 12 by 2, that is 20 by 2, that is 10. Now see, the x, that was the x value we have got here is 10, and the equal number that we got here was also 10. So through our formula we are getting exactly the same that we wanted, the x value for which all the numbers become equal, that is 10. So what we need to do is we need to just at the last the sum will be 3 into x. 3 into x will be 30. So 3 into 10 will give us 30, and initial the sum was 4 plus 8 plus 12, that was 24, and our minimum number of operations will be 3x minus s, that is 30 minus 24 equals to 6, and just we are getting our answer. So this was the formula that we have derived, although it's been long, but yeah, when we will implement this and we will again try run, if you will, you will see that it is quite easier. It was just I was explaining, so it became a bit long, but yes, let's try to implement this code. Let's quickly try to implement this. I will give the problem link in the description. Firstly we will just import in TCS NQT as well. We need to write this code from scratch, we need to take all the inputs, so practicing here would definitely help in examination as well. System.in, let's follow the input format. The first line contains an integer t, okay, that will the number of test cases. Next, for every test case, what we need to do is we need to take all the test cases. So I'll apply a loop until the test case becomes 0. We will take three integers a equals to sc dot next int. So I'll just quickly type the basic things. I've taken the input numbers a, b and c. Now since I need to sort them, I'll put them into an array. Array a comma b c, and I'll sort them using arrays dot sort. Okay, now what we need to do is we will apply the first condition, that is when if the parity of a, b and c are not same, then we will directly put the output to be -1. If a percent 2 not equals to b percent 2, or another condition, b percent 2 not equals to c percent 2. If this is the case, then what we need to print is -1, that is when parity is not same. System dot out dot println -1, and continue for the next test cases. Okay, now to get the minimum number of operations, what we did was similar the implementing the formula that we just derived, x as b plus c by 2. Firstly, one thing that I forgot here is when I put them into an array, and then again I'll initialize them, a as array of 0 because I have sorted them, right? Array of 0, b as array of 1, and c as array of 2. Okay, so this was our x, and the final formula for to get the min operations will be 3 into x minus a plus b plus c, and that's what we need to print here is minimum number of operations, right? Okay, let's just check, try to run our code. So for the test cases it is running. Let me try to submit it. Yeah, so it is passing for the test cases. You can also visualize this code on CodeChef and try to understand it by yourself as well. I also put this code into the description. I hope you understood this question. See here, line by line, this is a new feature in CodeChef. You can quickly understand it through an example. We can walk you through this. I hope you understood this question well, and for another such videos, more such videos, I'll continue in the next session. Thank you.